Hey guys, welcome back to the DAHKTUBE. And before we get started, don't forget to like, share, comment, and subscribe. Now, before you get started, ensure you watch the previous videos on logarithms before you get started here. Now, we're doing logarithms, solving equations of the form a to the x is equal to b. Now, why we use logarithms when we are in this form is because usually both sides of the equations cannot be written in powers of the base. For example, you know that with the laws of indices, let's say we had 2 to the x is equal to 4. We know that 4 can be written in terms of base 2. So we'd have 2 to the x is equal to 2 squared. Now, because the bases are the same, we could equate the powers. And we'd know that x would be equal to 2. However, there are cases where this term or one of the terms cannot be represented or expressed in the base of the other one. So, for example, let's say we have 5 to the x is equal to 8. So if you look here, you have one base being 5 and one being 8. And you know that, for example, 8 cannot be written in terms of base 5. So what we have to do is we have to log both sides of the equation. Now, with logging both sides of the equation, what happens is you have log 5x being equal to log 8. Now, the power that is here goes to the forefront. So now we have x log 5 being equal to log 8. So if we want to solve for x, we have to what? Divide both sides by log 5. So the log 5's here cancel, and we'd have x being equal to log 8 over log 5. Now you can input these values in your calculator by pressing log 8 divided by log 5. When you do that, the answer will be equal to 1.29. And this is to 3 significant figures. Another example, let's say we have 3 to the 4x minus 1 being equal to 8. So if you look here, you realize that 3 nor 8 can be written in any possible way as the same basis. So we have to log both sides. So it's log 3, 4x minus 1 being equal to log 8. So again, the power goes to the forefront. So we have 4x minus 1. I'd advise you to write it in a bracket so that you don't mix it up. Then you have log 3 being equal to log 8. So what we do now is divide both sides by log 3 as we're trying to get x by itself. So we have 4x minus 1 being equal to log 8 over log 3. So now you could simplify this here, then continue working, or you could just work it as is. So we'd have 4x is equal to log 8 over log 3, and you carry this over the equal sign, so it becomes plus 1. And then now you want to get x by itself, so you're dividing both sides by 4. So the 4's cancel, and you're dividing both sides by 4. So you'd have log 8 divided by log 3. You can work that out. Then add 1 to it, and then divide by 4. And you're going to get x being equal to 0.723. Another example, let's say we have 0.2 to the 3x is equal to 0.34. Again, we log both sides. So it's log 0.2 to the 3x being equal to log 0.34. And again, power goes to the forefront. So we have 3x log 0.2 be equal to log 0.34. So divide both sides by log 0.2 because we're trying to get x by itself. So that's 3x being equal to log 0.34 divided by log 0.2. So if you divide log 0.34 and log 0.2, you're going to get 3x being equal to 0.6703. Then you divide both sides by 3. So x will be equal to 0.2234 if you round it off. Another example, let's say we have 2 to the 4x plus 1 being equal to 3 to the 2x. Again, we log both sides. And the powers go to the forefront. So it's 4x plus 1, put that in a bracket, log 2 being equal to 2x log 3. Now what we want to do is to expand the bracket. So log 2 be multiplied by this, be multiplied by this. Why? Because we realize that we have an x term here and an x term here. So we have to do that to group our like terms. So we'd have 4x log 2 plus log 2 being equal to 2x log 3. So it's 4x log 2 minus 2x log 3. So I'll carry this over here, and I'm going to take this over here, equal to minus log 2. So now what we'll have to do is we have to factor out x because x is common between both. So we'd have x, and in bracket, 4 log 2 minus 2 log 3 being equal to minus log 2. So now we have to divide both sides by all of what is in the bracket here. By 4 log 2 minus 2 log 3. 4 log 2 minus 2 log 3. So if you input that in your calculator, you're going to get negative, so it's minus log 2 divided by open bracket, and then you substitute the entire denominator inside the bracket to get the final answer, which is minus 1.2047. Another example, let's say we have 4e to the 2x. So now because we have e, whenever you see e, you always think to use the natural log, which is ln. So instead of logging both sides, we're going to ln both sides. So we have ln 4e to the 2x equal ln 5. So here you realize that this is a product of two things, 4 times e to the 2x. So because we're doing a product, that means we have ln 4 plus ln e to the 2x being equal to ln 5. So now we'd have ln e to the 2x being equal to ln 5 minus ln 4. So we take this over the grouping like terms. So now we can actually take the power to the forefront. So we'd have 2x ln e being equal to ln 5 minus ln 4. Now ln e is equal to 1. So it'd be 2x times 1. So that's 2x being equal to, and then we have ln 5 minus ln 4. So we know from the law of logarithm, that's the same thing as saying ln 5 over 4. So that means x would be equal to ln 5 over 4 divided by 2. So x is equal to 0.112. So the last question we're going to do here is 25, 5 to the x is equal to 48. So now, again, we log both sides. So it's log 25, 5 to the x being equal to log 48. So because here we have a product, that means we're going to be adding. So we have log 25 plus log 5 to the x being equal to log 48. So we have log 25 plus, because the power is here, we have to take the power to the forefront. So that's x log 5 being equal to log 48. That's x log 5 being equal to log 48 minus log 25. Now again, because we're subtracting, that means we're going to be dividing the logs. So we have x log 5 being equal to log 48 over 25. And then we're going to be dividing that by log 5 to make x the subject. So that means x would be equal to 0.405. So that is all to solving equations of the form a to the x is equal to b. Thank you guys for staying tuned, and I'll see you guys next time on the Dark Tube.